Today, we're diving into something that is literally reshaping the whole landscape of artificial intelligence. I'm talking about the Model Context Protocol, or MCP for short. Look, if you've ever tried to get an AI model to actually do something useful with your own local files or, say, your company's database, you already know it is incredibly frustrating. It's a huge headache. Well, MCP is stepping in as the brand new standard protocol to fix all of that. So let's jump right in and break down exactly how it works. Here's our quick roadmap for today. First, we'll look at the AI integration headache. Then, we'll meet our solution, the universal adapter. After that, we'll break down MCP's 4 core components, and we'll wrap up with a look at the growing server ecosystem. Let's get to it. All right, section 1. Let's start with the big problem, the AI integration headache. We really have to start by asking, why is connecting AI to our external tools so hard right now? Seriously, before this new protocol came along, the whole landscape of AI tool binding was just completely fractured. Think about it. If you wanted to build a multi-model system, you were essentially starting from scratch every single time. And why? Because there was absolutely no standard. Every individual model provider just made up its own specific tool calling format and its own totally unique message structure. And this is where we shift from a total point-to-point nightmare to a beautiful hub-based dream. In the old way of doing things, that highly fragmented point-to-point mess, you were literally forced to rewrite your custom integration code for every single model provider you wanted to use. It's a massive bottleneck, right? But now, look at the new hub-based integration pattern that MCP brings to the table. Instead of this tangled web of custom code, multiple models can now access multiple distinct toolsets seamlessly, all through one shared protocol. It just instantly wipes out that fragmentation. Moving right along to section 2, let's meet the solution to all this, the universal adapter. I absolutely love the analogy our source material uses here. Think of MCP as the USB-C of AI integration. I mean, we all remember the absolute nightmare of having a different charging cable for every single electronic device in the house, right? And then suddenly USB-C comes along and standardizes the whole shebang. Well, just as USB-C connects any device to any cable, the Model Context Protocol connects literally any MCP-compatible AI service directly to any MCP-compatible tool. It is a true universal cross-platform interface. So, the really crucial takeaway here is just the sheer relief of this efficiency. You build your tools exactly once, and any model can use them. That's it. You no longer have to burn your precious time building and maintaining custom integrations every time a new AI model hits the market. You do the hard work one single time, and the protocol just quietly handles all the translation for any model you plug into the hub. But how does this actually work under the hood? Well, let's dive into section 3, MCP's 4 core components. First up in our little cast of characters, we have the clients. You can really think of them as the orchestrators. Basically, a client is the AI service or the orchestration system that actively wants to use a tool. So, say you're building a custom AI agent, or maybe you're using a chat interface or an IDE to talk to a model. Well, that's your client. Its whole job is to maintain the connection and actively manage the conversation. Next up, we've got the servers. These guys act as the providers. They are the independent systems that are actually exposing the tools or the data to the client. Now, a server could be something like a custom test validation service you've set up, or honestly, it could simply be your database. The key thing to remember here is that each of these servers runs completely independently, and they just expose their capabilities outward using the MCP protocol. Coming in third, we have the data sources. So, if the client is the orchestrator and the server is the provider, then the data sources are the actual tangible assets being requested. We're talking about the specific individual files or data records that a server makes available. For instance, if you're asking an AI to troubleshoot a piece of physical machinery, the data source might literally be a PDF file called hardware_manual_content. Or, if you're debugging software, it's probably going to be your raw system_log_data. And finally, the glue tying this whole system together is the protocol itself, which serves as the language. This is the common communication format. When a client wants to invoke a resource on a server, it doesn't just, guess how to ask. It sends a highly structured message in the exact MCP format. The server then processes it and fires back a response in that exact same format. This shared language is the absolute magic ingredient that guarantees everything plays nicely together.
Now, behind the scenes, MCP relies on some incredibly flexible transport mechanisms. You can implement it over standard input/output or Stdio for your local servers, or you can use HTTP-based transports if you're dealing with remote servers. On top of that, it packs in some really advanced capabilities, giving developers tight control. For example, the protocol lets models understand specific routes or boundaries of a local file system, so the AI only accesses what you actually want it to see. Then there's sampling, which is super cool. It's where the server can ask the AI model to temporarily review or sample specific data to help push a workflow forward. Oh, and it also includes elicitation. That's a powerful feature that lets the system securely prompt the user for missing info, like an API key or a password, without you having to hard code any sensitive secrets into your codebase. Really smart stuff.
Okay, section 4. Now that we've got the architecture down, let's look at the real-world applications in our final section, the growing server ecosystem. This ecosystem is already absolutely thriving. You can really see how rapidly Anthropic and its partners are building this out across all the major categories. I mean, for databases, you can now easily connect your AI to heavy-duty systems like PostgreSQL or MongoDB. Need file systems? You can read and write files directly on your local or cloud storage. They've got generic HTTP API clients ready to go. And for third-party integrations, the everyday tools we all practically live in, things like Slack, GitHub, and Jira are all perfectly primed and ready to be plugged in via MCAP.
So the crucial point for your own workflow here, and honestly, your biggest takeaway to save yourself a ton of time, is this. Always, always check if an MCP server exists first before you start building from scratch. By leveraging an existing server from this growing community, you are looking at writing significantly less custom code. Plus, you get the massive benefit of better, centralized maintenance and all those ongoing community-driven improvements, all without you having to lift a single finger.
So there you have it. We've seen exactly how MCP cures that massive integration headache, how it acts as the universal USB-C for AI, and how it operates through a beautifully simple 4-component architecture. To wrap up this explainer, I want to leave you with a little something to think about regarding your own technical setup. Take a hard look at your daily workflows, your databases, your communication platforms. Which of your tools are you going to plug into the AI matrix first using this new universal standard? The possibilities are finally genuinely streamlined, and honestly, the choice is entirely yours.